Hello there, Math 133 students. In this video, we're going to go over the flow chart for confidence intervals in Chapter 11, which of course also includes the Chapter 9 confidence intervals that we learned also. So let's begin up here with the 1 prop zint versus the 2 prop zint. These are both for proportions, right? So in both of these, you're going to see proportions, percents. So if you see a percent, roaming around the problem, a survey, but this is going to be for one group. And down here, it would be proportions, percents, surveys, but for two independent groups. Two separate, I guess I should say, two separate independent groups. So this one was the one we learned about in Chapter 9. So this was section 9.1, this one, whereas this one was section 11.1. So this one's about single proportions. This is about comparing two proportions from two independent groups. So for this one, we need to have normality, we need n times p hat times 1 minus p hat must be greater than or equal to 10. And the parameter we're trying to create this interval for is, of course, the population proportion p. And we learned about this in section 9.1. And it's on page, if I grab our gold packet here, it's right here, 9.1, it's page 300, but at the top. All right, so now down here for the one for two proportions, that's on page, this was section 11.1, and so it's on page 303 at the top. Right, it's the first box, I guess I should say. And same here, it's the first box on that page. Okay, so this is for the parameter P1 minus P2. So you're trying to figure out where the difference in proportions is. So it's the proportion in the first group minus the proportion in the second group. So it's the difference in the population proportions. And the normal requirement is a little bit larger. You need to do what we did for Chapter 9, but you need to do it twice. You need to do it for each separate group. So you need N1, your sample size for group 1, times P1 hat times 1 minus P1 hat to be greater than or equal to 10. You also need N2, P2 hat, 1 minus P2 hat to be greater than or equal to 10. So you need both of those things to be true. All right, now those are the two that are for proportions, because everything we do, of course, is for proportions. So this is proportions, and this is proportions. Single, double. Now we have to look at the mean ones, which are the three down below, of course. So for means, we have three options. We have the one that we learned about in section 9.2. That's for a single mean. Then we have the ones that we learned about in section, or in chapter 11, if you will, which are for this one's section 11.2 and this one's section 11.3. They're both for means, right? But this is for the mean of differences, right? The differences. And this one is the difference in means, which I know sounds the same, but they're not. Okay, what do I mean by that? Okay, well, they're both going to be talking about, or all of them are going to be talking about averages, so I can just get that out of the way. They'll talk about average, they'll mention mean, they'll mention standard deviation, or you might have a data table, right? So that is true for all of these. So average, mean, standard deviation, data table. But the data table will vary for the two or the three of them. All right, so far all of this is the same. So how are we going to tell the difference between them? Okay, well, this one's going to be for a single group, for one group. This one's for two separate independent groups. And this one's for a dependent group. Now, what's the difference? Well, the top one is just a single group of data. This one would be, if you look at a data table, it'll have joined up pairs. So a dependent group is, of course, oh, and I guess I can put that down here. Dependent group, so note, dependent group is one group measured twice, like before and after. Husbands and wives, brothers and sisters, right? They're related to each other. So it's one group of relatives and you measure each relative. Or before and after, pre, post is the most common one, for example. But it's not the only type. So pre and post, relatives, people that are related to each other, so that's another common one. Relatives, there we go. So you'll get husbands and wives, brothers and sisters, that kind of thing, etc. That's what a dependent group means. So when you see that dependent group, that data table is going to have joined up pairs. It's going to be matched pairs. That's another way to put it. They're matched pairs. That's a dependent group. All right, so when you see that dependent group and you're making a confidence interval, it's for the mean of the differences. So instead of just mu, it's the mu of the differences. It's mu d that you're building your interval for. So it's the mean of all the differences, mu d. Down here, if they're two separate independent groups, right? Two groups completely measured once, measured completely different from each other. They have no relationship, as opposed to dependent groups, which have a relationship. So what you're looking for there is the difference of the means. So you're looking for, hey, how does the mean for group 1 differ from the mean from group 2? So this one here from chapter 9 is a single mean. This is the mean of all the differences. So you take your dependent group and you find those differences, those d values, and you're guessing where the average is for all those differences. And then this one is group 1, group 2. They're separate from each other. What is the difference in those means? So mean of differences, difference of the means. So this is section 9.2. This was section 11.2. This was section 11.3. So this particular one's on page 300. It's the second box on page 300. So if I grab my gold packet really quickly, although mine's not gold, but you can see page 300. There, it's that one, 9.2. And the other ones are on page 303, right there. So T interval for the differences, for the matched pairs, and then 2 samp T int right here. Okay, so this one's page 303. This is the second box. Oh, my end got weird there. Second box. And this is page 303. This is the third box. Right. Now you'll notice the calculator entry for these two is actually the same. T interval and T interval for differences is the same calculator step. It's T interval. It's just a question of, are you talking about one group or are we talking about a dependent group where you found differences, right? So did you find the differences for them or not? So they actually have the same calculator entry. Now the normal requirement for them varies slightly. So for the normal requirement for this, we need given graph or n to be greater than or equal to 30. So that's true here. It's just that the n is the n of the differences. It's how many matched pairs you had. So it could be given, again, it could be a graph, or it could be the n differences. So how many matched pairs were there? It better be more than 30. If it's not, then hopefully you have a normal probability plot to get you out of it. And then down here for this one, it could be given, of course. It could be graph for both of them. Or you could have n1 greater than or equal to 30 and n2 greater than or equal to 30. You have to have both. It has to be required. So you have to know that both groups were normal, both group 1 and group 2, because they're separate and independent of each other. As opposed to this one, where it's really there are two groups that are tied together, so they really form one group of differences. And it's that group of differences, that ND, that has to be greater than or equal to 30. Even though on the sheet, I actually wrote N, but it's really the number of, in the sample, which would be the number of differences that you found. So you could put a little D in after that in your head if you wanted to. All right, now there are two types of critical values that we can find. So there's either T alpha over 2 or Z alpha over 2. So the ones that have Z's in them, here, let me grab a color. So if you see Z right here, these two types of intervals use critical Z values. So for the proportion ones, it's plus or minus Z alpha over 2, which of course you find with either inverse norm alpha over 2, comma 0, comma 1, or you find with the bottom row of the t-table. So those are the Z ones. The two proportion ones are the ones that use the Z. So if you want, you could put a little prop next to these, right? The proportion ones are the ones that use the Z. The mean ones use T, and you can see it right in what the calculator is telling you. So T, T, T. They're using T as their critical values. So for the mean ones, it's plus or minus T alpha over 2, which you can either find with inverse T alpha over 2 comma degrees of freedom, or the t-table. And again, remember, we've learned it several times, but one more note, degrees of freedom is equal to n minus 1. Just a little reminder.